we've defined systems of equations and we've solved them graphically and also numerically, and we've also looked at some applications. Now, the problem with sometimes solving graphically is, what if the solution does not yield a nice point? You know what I mean? Like, you can see on the graph where the lines cross, but it might not be a clearly distinguishable point, right? It might not be like -2, 3. It might be somewhere between integer values. And you're not going to be able to to know what the exact solution is just by looking at the graph. I mean, you can estimate it, but you won't be able to find the exact solution. So you do also need some algebraic methods to solve systems of equations, one of which is going to be called the substitution method. Okay, and the first thing you want to keep in mind with this substitution method for systems of equations is you're going to use it generally when at least one of the variables in either of the two equations has a coefficient of 1 or -1. So you're basically looking for like an x or a y that doesn't have a number in front of it. Okay, right? It means that there's no number in front of at least one of the x or y value or y variables in either of the equations. So what's the process for solving by substitution? You solve one of the two equations for one variable in terms of the other, right? Which we had done already when we did that section on solving formulas. Then take the expression that you got in step one and substitute it into the other equation. And what that does is that'll create a new equation that now only has one variable. And then you can just solve that equation normally, right? Because it only has one variable now. So then once you solve for the one variable, you take that solution and substitute it into either of the two original equations to find the other variable. And some people require that you write the solution as an ordered pair, but to me that's not important. You can either write the solution as an ordered pair, or you can just write it in the form x equals some value, y equals some value, right? You don't have to necessarily write it as an ordered pair. So we'll look at a couple of these. All right. And I still didn't do that tying it together thing that I had said is important for systems of equations, right? When you see a system of equations, you generally should see it like that, right? With that little squiggly brace to indicate that, they're being considered as a group, right? Together as a system. So if we follow this process, we can go through this, right? So y equals -2x plus 4, 2x minus y equals 8. Well, the first step is to solve one of the two equations for one variable in terms of the other, but that top equation, that's already solved for y. It's solved for y already. So step one is finished. So all I really need to do is now go to step two and take that expression that I got in step one, right, which namely is -2x plus 4. That's the expression I'm talking about, because that's what y is equal to. And I substitute that into the other equation. So I'm going to place this -2x plus 4 into the other equation for y. Okay, so what does that look like? It looks like just rewriting the bottom equation. But now wherever I see a y, I put -2x plus 4. And the important thing to remember is how I put the parentheses around that. You're going to need to place this -2x plus 4 in parentheses, because you're going to have to distribute that negative sign to it, right? So all I did is I replaced y with -2x plus 4. But other than that, I rewrote the equation exactly as it was, right? So now I would just solve this. Right now I'm at step 3. Well, no, I'm still in step 2, right? I have the equation in one variable which can be solved. So now I distribute this negative sign, so this becomes 2x plus 2x minus 4 equals 8. And now I just solve this with my regular equation solving process, right? Combine like terms, add 4 to both sides, and then divide by 4. So I would end up with x equals 3 in this case. So that's one of my solutions, right? That's half of my solution, basically, right? That's the x value of my solution. So now I'm on step 3. I take the solution from step 2, which is x equals 3, and I substitute it into either one of the two original equations. So it's easiest just to use the top equation, because the top equation is already solved for y. So I'll take this 3 and I'll substitute it now for x in my top equation, and I'll have y equals -6 plus 4, so y equals -2. And honestly, for me, that's sufficient, because you've clearly identified both the x and the y value. Now, if you really want to, you can just go separately and say, all right, the solution is 3, -2. right? So I'm saying you can either write the solution as an ordered pair or just have x equals 3, y equals -2 separately. Either way works for me. So now we'll look at another one here. Now this other one, step 1 is not completely finished, right? So what do you have? You have x plus 2y equals 2, and you have 3x plus 5y equals 1. So remember, what you want is you want to solve for a variable that has a coefficient of 1 or -1. That y has a coefficient of 2. That x has a coefficient of 3. That y has a coefficient of 5. The only one that has a coefficient of 1 or -1 is this x. So that's the thing I want to solve for. And you see why it's very easy to solve for. How do I solve for that x? I just move the 2y to the other side. So I would have x plus 2y equals 2. And if I subtract 2y, I'm just going to have x equals 2 minus 2y, or -2y plus 2, however you want to write it. And this is now my expression, right? So I just did step 1. Now this is my expression that I'm going to substitute into the other equation for x, right? So I'm going to take this 2 minus 2y, and I'm going to put it right there in the other equation. So what I'm going to do now is I'm going to rewrite the bottom equation as 3 times parentheses 2 minus 2y, so that's x now became 2 minus 2y, plus 5y equals 1. And now I just solve normally, right? Distribute, combine like terms, subtract 6. So -y equals -5, but then remember, you got to divide by a -1. So this becomes y equals 5. And since I was running out of space, that's why I didn't show all the steps. But you should be showing how you're, subtracting 6 on both sides, dividing both sides by -1, and then you get y equals 5. And now I just go to my last step of substituting this into one of the two original equations and finding x, right? So I'll use the top one. So if I now rewrite the top one, replacing y with 5, I have x plus 10 equals 2, and then I subtract 10, so I'm going to get x equals -8. So in this case, my solution is x equal -8, y equal 5. And again, you can write it as -8, 5 if you wish. So either one of those methods of writing the solution is fine. All right, and then what you should do probably is check it into the other equation, right? So I just use the top equation to find my x. Now I can actually use the second equation, the bottom equation, to do a check. So if I do a check in the bottom equation, what do I write? I would write 3 times the x value, which is -8, plus 5 times the y value, which is 5. That should equal 1. So does it? Is -24 plus 25 equal to 1? Sure. 1 equals 1, so it does check. All right. And I mean, you can check it in both, but since I used the top equation to find my x value, I figured it wasn't necessary. And the same thing with the one on the left, right? I could have plugged the point 3, -2 into the bottom equation and made sure that it checked. And again, you should do checks on the calculator rather than just do them in your head, because I've seen people make errors on checks when they had the right answer. So you got to be careful with those. Okay, so those were a couple examples of solving systems by substitution.